Alright, so next let's move on to basic mathematical functions. So square root, log 10, log 2, exponent, exp, that's exponential, sine, and mode, right? So sqrt is the square root function. So to take the square root of any number, you just write sqrt and then in brackets that number which you want to take the square root of. Then the natural log, log, not ln, log is the natural log. Log 10 base 10 log, log 2 base 2 log, exp, e raised to the power of x, where exp is your exponential, sine. So sine gives you the sign of a number. If it's a positive number, it returns 1, positive 1. If it's a negative number, it returns -1, and if it's 0, it just returns 0. Then mode is the modulus, the remainder after division. Let's check each of these up. So sqrt 9 is 3, sqrt 8, square root of 65. The square root of 65 is 8 something, right? Yeah. So square root of 90, square root of 3125, square root of 625, square root of 900. Okay, so that's the square root function. So log is the natural log. So if you have taking the natural log of a number, right? So then log 10 gives you the base 10 log of the number. Log 2 gives you the base 2 log of the number. So this give you 2. This will give you 3. This also give you 3. Then what's the next one? Exponential. Yep. So exp, let's say 1 give you 2.7183, and so on. So if you take the exponential of the natural log of a number, I don't think you're supposed to use 1 here to give you that number back, because exponential and natural log cancel themselves out. Yeah. Okay. So sine and mode. So sine, as I said, just gives you the sign. So if I have a negative number, to give me -1 as the sign. If I have a positive number, it gives me +1 as the sign, and if it's 0, it gives me 0. Right. Then mode just gives you the what do you call it? Remainder after division. Remainder after division. So if I'm dividing 4 by 5, still be 4, because 5 cannot go into 4 without remainder. Yeah. So if it was 5, 4, you put the dividend first. So the dividend goes first, and then the divisor goes second. So that's the number, the numerator essentially goes first, the denominator goes second. So if I divide 5 by 4, 4 will go into 5 once, then the remainder will be 1. So if we did that with 10, the remainder here would be 3. If we did that with, the remainder would be 10. If we did the opposite here, 100 will not be able to go, so 0 remainder 30. Okay, so those are the basic math functions. Next, trigonometric functions. So MATLAB has a lot of trigonometric functions. Oops. So sine, we've seen sine, cos, tan, all these. MATLAB has them all. So sine, so if you go help sine, we've already seen that this takes the sign of a number in radians, not degrees. So if I did sine 90, 90 here would be in radians, not degrees. So if you wanted it in radian, sine pi over 2, which is sine 90 in radians, will give you 1 cos pi over 2. This cos 3 pi over 4. That's so cos so tan pi over 2. This is tan 90. Tan pi, sorry, yeah, this is tan 90. Tan pi will be tan 180. Right, so tan 30. Remember, all these values that you're passing will be in radians, not degrees. If you want the degrees equivalent, it would be sine d. So sine d will be sine 90 in degrees. Cos d would be cos 30 in degrees. So the d indicates that the number you're passing, the angle you're passing in is a degrees. It's in degrees. Okay. Then, so there's also a tan and a sine. That's arctan, arcsine, arctan, arcsine. Okay. So the what do you call it? The inverse of whatever the inverse operation to the sine and the cos and the tan. You just add an a to the beginning. All right. Then there's also degree to rad and rad to degree. So converting angles from degrees to radians and from radians to degrees, use the degree to rad and rad to degrees. The degree to rad converts a number in degrees, an angle in degrees to radians. So this is pi over 2. So if you're converting to radians, let's say pi over 4. So if you're converting to from radians to degrees, you would use the rad to dig function. So radians to degrees, let's say pi, so be 180. Radians to degrees, pi over 2, to be 90. Okay. So if I wanted, instead of using sine d, I could use sine expecting an angle which is in radians now. So degree to radians will then convert. Remember, you're passing, since these are functions, everything you do, you put parentheses so that the arguments will be passed in. So the arguments are what the function takes in. Function just takes in an input and gives you an output. So the input will be put in parentheses. So for the sine, I'm passing in number now that will be converted from degrees to radians. So if I put 90 here, I'll get 1 because this sine function is taking in radians. And this function here converts this number here from degrees to radians. Okay. So these are some of the trigonometric functions. So sine cos tan, sine d cos d, tan d, degrees to radians, and radians to degrees. Alright. So let's do it this way. So if I had data in radians, which is pi over 2, theta in degrees will be radian to degrees, theta in radians. Oops. That's converted from degrees now to radians. Sorry, from radians to degrees, and that's 90. So if I use my sine d, theta in degrees 1. So from pi over 2, converted it to degrees, because this is in radians, converted it to degrees, and then passed it to the sine function, the trigonometric function that takes in angles in degrees. Okay.